isolated, conjugated, cumulated. Do you know the difference between those three?
Yeah, isolated is when there's a single bond that separates them.
Yeah. And then conjugated, what we
When
go over.
There's not, all the carbons are kind of like stuck together. There's not a full single bond.
And then when we have this guy, when it's accumulated, this right here can be chiral. Because this is chiral, so you got to think.
The molecule is chiral.
Okay, so when you're forming a double bond, the whole idea of the double bond is that your p orbitals are parallel, right?
Right.
So these two are parallel to each other, but then here, your p orbitals will have to be angled because this p orbital can't be in the same spot that p orbital is. So because these are angled, it causes this is to remain trigonal planar. These two have to be, they're not going to be planar on the board, they're going to be offset.
Okay.
They're still, this carbon's still trigonal planar, but it's tweaked a little bit.
So if that fluorine was a bromine, would it still be chiral?
Let's see. I think you have to have at least 3 unique things on it with this system. So we draw its mirror image, and then we were to superimpose them. No, I do think it has to be different. These two have to be different from each other.
Okay.
So then if we try to superimpose them, so you're going to flip it 180, so then bromine's overlapping, that fluorine would be sticking out. So they're not superimposable. They are mirror images. So if you have a cumulated system, it can have an enantiomer, it can be chiral. Now you don't really label this S or R because you don't have, these carbons have 3 things on them, so they can't really be labeled that way.
And then when you're looking at a diene, do you still have to, is it still like trans and cis?
You can still take E and Z.
Or yeah, E and Z.
You can do those as well.